Okay, so the next section, the deferred annuities. So example 1, what is the present value? Okay, so think about the time diagram. And t start at 0 and 1, 2, 3, 4 up to 9. And the $1 is deposited each time, but the starting at 3 and end at 9. So we have in total the 7 payment of 1, but it starts at t is equal to 3 and ends at t is equal to 9. What is PV? So PV is here. We have 2 ways to think about it. So at first, the one way, this is the new one. This is the, okay, so we think about this as the difference in 2 different annuities. So one annuity is the $1 for 9 years, t is equal to 1, 2, 3, 4, up to 9. And another annuity is annuity for only 2 years, 1, 1. Okay. So, okay, so think about this cash flow and this cash flow. And the first one is just the annuity for 9 years, annuity immediate for 9 years. So the present value is A right angle N. So suppose we have some fixed annual interest, for example, maybe 4%. Then V is 1 over 1 plus I. So this is 0.9615. And the second cash flow, so this has the present value of A right angle 2 because this is the annuity for 2 years. But if we take the difference between these two, so first one minus second one, then the remaining amount is this cash flow we want to evaluate. So that's why the PV is equal to the A right angle 9 minus A right angle 2. And both are easily calculated by the VA2 plus or just formula. If you use your hand, then just this. So 1 minus 1.04 to the power negative 9 over 0.04 minus 1 minus 0.1 minus 1.04 to the power negative 2 over 0.04. So this becomes actually the 5.549. So about $5.55. So this is one way to solve this. So the deferred annuity, that is, okay, so 2-year deferred, then we just calculate A9, A right angle 9 and A right angle 2 and take the difference. And another way, maybe a little more straightforward one, is that we evaluate the value at time 2. Okay, so time 2. So we evaluate the value at time 2. So maybe here. Then we go back 2 years. So maybe go back 2 years. So we multiply with square. Or PV to X, we have to multiply 1 plus I, the square of 1 plus I. So so the solution 2 is that at first they evaluate at time 2. So value at t is equal to 2 is equal to A right angle 7. So this is 1 minus I, V to the power 7. So V7 over I. So this is 1 minus 1.04, negative 7 over 0.04. And this is equal to the 6.002. Okay. Then value at time 0, present value, is equal to this 6.002 times the v square. So this is 6.002 times 1.04 negative 2. And this becomes 5.549 again. So in either way that we can solve this. And we write this, the deferred annuity, as two vertical line, the A right angle 7. 2 bar A right angle 7. So in general, the M bar A right angle N, this is equal to A right angle M plus N minus A right angle M. So previously we calculate the A right angle 9 minus A right angle 2, right? This is basically a 7-year annuity, but the 2-year deferred, so 9 minus 2. And here, A right angle M plus N and minus A right angle M. And in the second solution, that we use the fact that basically we can use A right angle N, but we have to go back M years, so the V to the power M. So we can have the two formula. M bar A right angle N is A right angle M plus N minus A right angle M, or the V to the power M times A right angle N. So this is how we can calculate the present value of deferred annuity.